Longer battery life is important for mobile phones and other mobile devices. Short of a breakthrough in new battery technology, the easiest way to make improvements in operating life is to accurately characterize the dynamic battery current drain of the device and reduce the drain where possible. Batteries are very non-ideal energy sources. A battery's internal impedance and other characteristics interact with the circuit behavior of a mobile device, influencing its resultant current drain. Accurate current drain measurements are essential in order to optimize your mobile device's battery runtime. This screenshot shows the pulsed current drain and voltage response on a GSM mobile phone powered by its battery. As can be seen, a battery has substantial series output impedance, causing its output voltage to drop in direct proportion to the mobile device's current drain. Many mobile wireless devices adapt and adjust accordingly to compensate for the battery's characteristics. A general-purpose DC power supply strives to be an ideal voltage source with zero output impedance by using feedback to regulate its output to a fixed voltage setting. Unlike a battery, its voltage does not drop proportionally with load current. Also, feedback regulation has finite response time. This leads to transient voltage drops and overshoots during loading and unloading transitions. This screenshot shows the same measurements made as before using a general-purpose DC power supply in place of the battery. The voltage response is very different, and the resultant current drain ended up being 10% higher than when using the battery. As you can see, a general-purpose DC power supply is not a good emulator of a battery used in a mobile device. If a transient voltage drop is large enough, it can even trigger a mobile device's low battery voltage shutdown mode. In contrast, programmable DC sources tailored for powering mobile devices have capabilities for emulating batteries, including extremely fast load transient response to minimize voltage drops and overshoots, and accurate emulation of a battery's dynamic voltage response. Programmable series output resistance to emulate a battery's impedance. Current syncing in addition to sourcing to emulate a battery's charging current characteristics. Agilent Technologies has superior tools designed specifically to emulate the battery of a mobile device. The N6781A source measure unit is tuned for battery drain analysis. When combined with an Agilent 6705B mainframe and 14585A software, it is a superior solution for measuring and analyzing battery current drain in devices such as mobile phones. This screenshot shows the same measurements as before, but this time using the Agilent N6781A SMU with battery emulation capabilities in place of the battery. The N6781A's series output resistance was set to match the battery's 150 milliohm value. Both the voltage response and resultant current drain is comparable to that of the actual battery. To summarize, a general-purpose DC power supply does not behave like a battery, often providing very different current drain results. Using a DC source with battery emulation capabilities helps assure that you achieve more accurate results, comparable to that of a real battery. For more information, visit the Agilent website at www.agilent.com/find/N6781.